Hi, in the previous sessions we created our view model. To some extent we almost completed it, but there were some problems regarding setting up the view model to work with our project and also getting some live data from it. And now we're gonna fix that. Actually, I have fixed it, and I'm gonna walk you through the steps that I took to do it. And after that, I will show you how to use that view model in your Compose applications. So let's go to the project view, and here take a look that we have our source code. In DB we created our DB related files and classes. The one in question was cost view model, which was the important one. Okay, this version of Android Studio. Note that I'm using the new Canary version of Android Studio. That is a little bit weird. I forgot its name. Something like Fox or something. And in order to use it, we are going to make some changes. We are going to upgrade our Gradle version to this version. So if it's better to do it with automatic method that Android Studio automatically does, and it's gonna show us to use this method. Note that the versioning of Android Gradle dependency has changed from Android version to Gradle version, looks like. And also Gradle version is gonna change to 671. So if this is 671, why is this Gradle? I don't know. Upgrade. Yeah, cost view model, I open it. Note that the problem was in previous session that we couldn't get this result as live data from our costs, which is live data. This costs is actually live data, and if we go to repository we can see that actually. Note that in repository we have costs, that is a flow of list of cost, and it's in turn obtained from cost DAO that returns to us a flow of cost. We receive that, we pass it to costs, and costs inside the repository passes that to our view model, and then our view model gets it as live data like this, and then we can do whatever we want with it. Another thing was about cost view model factory, that I think we completed this part. It's not very difficult, it's easy. You can also check that out from the documentation and room tutorial on d.android.com. It just creates a view model from this class using our application, I think, using our application instance. Yeah, view model, create view model class, and then is assignable from cost view model, and returns a cost view model repository st. Okay, now the next important thing, once we have our let me tell you one thing more. If I didn't mention it in previous session, we have cost application. This application is also used in the initialization of our room database. For example, we have this application scope that is initialized with coroutine scope, and we have database that is initialized by getting a single instance of our application, a singleton instance of our application, and we have a repository that is obtained by calling cost repository, actually initializing a new repository via a lazy method. Alright. Now the next more important thing that we have in our it's in our applications activity, where we will actually have access to our custom view model and want to use it with our compose project. And here we go, we have main activity, and in our main activity we create an instance of our view model this way. I think this is pretty small. Let me go to presentation mode, view tool window appearance, and enter presentation mode. It should make things a little bit bigger, and there we go. As you can see, we have access to our view model by calling view models, which is a composable. Actually, it's an inline function that helps us get a lazy delegate, as you can see, to access component activities view model. If factory producer is specified, then view model returned by it will be used to create view model first time. Class my component activity, and my view model by view models. So this returns our view model that we specify. The view model is custom view model factory that in turn creates our view model. Note that the definition of view model said that you specify factory that returns a factory that producer is specified, then view model provided that factory returned by it will be used to create view model first time. So here's the case, that's the case. And once we have the view model, we can use it to pass to our composables. Like in our home screen, we can pass it to home screen so that home screen can work on it, and like add some new data to our database, remove some data, and then we have our nav host, which defines different destinations and composables for our application. One of them is the home composable that we can follow the definition of down below. We have the view model received here, and then we pass that view model. Actually, we have the view model and in this, and we can get our data from our view model. How? We do it by doing cost view model dot costs and then observe as state. Note that as many other state types, in order to work with some data in composable, you need to get a state reference to it, and this is a reference state to our view model data. Observe as state, and since this is live data, you can call observe as a state on live data. And then we have the costs, whose type is, I don't know what yet, state. I think it's kind of a state data. And then we use these costs, which are a collection of data, to, for example, display a list. This is very important and very convenient. Note that once the user adds something, in our other composable, in our other destination, which is new item composable. Once the user adds a new cost, including a name and its value, it automatically and instantly updates our ViewModel's data, which results in a new recomposition happening, and then a refresh, a very instant refresh in our list. So the list updates and our lazy column or our list updates with the new data. Once this build completes, I will be able to show that in action, and you will see that it works very perfectly. Once again, we take a look back to our destinations. One of our destinations was home, where we display our list of data, and the other is new item composable or route, which allows the user to enter a new cost and its value, and then once they hit save, it is added to our view model by calling ViewModel dot add cost, and you can see that both in ViewModel's definition and also in our DAO definition. Let's check out this composable new item. It receives a nav controller, which it needs for navigation, and it also receives a cost view model instance, and this cost view model adds a new item once the button is clicked. The button is the save button, actually. So cost view model add cost, it adds the cost name and cost value to the view model, and then returns to the home route where the list is displayed with the refreshed and updated data. Alright, and its text, this button's text is save, as I mentioned. Don't show it again, just direction, context space, don't show it again. Alright, I think we are ready to run the application. Type variable list cost, list found list cost, list variable list cost, observe as a state, observe as a state. What is this error for? Observe as a state. We are observing our lists of costs as state, but the thing that this expects is a list of type variable t. Alright, I think I have the correct version of this code. Let me do a get poll from master. Probably this will be fixed once I do that. Okay, what is that? There's some problem. I need to get rid of my local changes. Let's stash it. Stash my local changes. Local changes. Okay. just view model. How new is this code? View model. And then if I do git pull, what will happen? It probably is gonna work this time and add some more code that is more updated than this version. Yeah, looks like we have some new changes. Observe as a state. Yeah, cost value let. We say if the costs are actually not null, then we can use them in our list to display them. Actually, let's run it. Run the app. We have to wait until this runs and the compilation is complete, and we can see the output on our emulator. But we could also use the embedded emulator, and that's not a bad idea actually. Let's enable it for future runs. I go to edit and then file and then settings, and here we can find some, let's say we can, where was it, other settings, tools I think, and then the emulator, yes, launch in tool window, to launch in a tool window, otherwise launch as a standalone application. Okay, this allows us to run it embeddedly next time, of course. The build was finished installing. There we go. There are two costs already added. We can add some more items, and you can see the effect of our view model and our code that we used in our compose application here. So the first is the cost name, like vegetables, eggs, in fact, eggs 10. Save it. Once we save it, it automatically updates our view model and the list is recomposed in our home route or in our home composable. Very beautiful and very nice. So that's it. You see, only the only tricky part was in setting up the view model, but getting access to the view model was not that difficult. In fact, the only thing that we needed to do was calling this delegate by using delegate, the definition to call view models, and then getting a new instance of a view model from its factory. This gives us the view model, and from the view model we get the repository, and repository, no, actually we don't get the repository. This part is just used for creating the view model, passed into create the view model, and eventually we have the view model here. This gives us the view model that we need to create our state, and then we use our state here, like cost view model dot costs, which gives us access to the live data, and then live data is turned into a state object by calling observe as a state, and then the rest as you know. There are some important parts that you need to be aware of, like the changes that we made in our build.gradle file that I made. Actually, there are some dependencies that are very important. Lifecycle ViewModel, lifecycle, live data and lifecycle, common Java 8. These are very important dependencies. If you don't add them to your application, you will have problem resolving some dependencies, and probably you will not be able to create your ViewModel. And also coroutine, Kotlinx coroutines core, and Kotlinx coroutines Android, and Kotlin stdlib, the standard library of Kotlin. These are all very important dependencies that you need to add. Of course, I will put a link to the code in this project below this video, so feel free to check out the code and try it on your system. And if there's any question, let me know. If you like the video, please hit the like button and subscribe to my channel. I really appreciate it, and see you in the next video.